Okay, so today we're going to dive into the thinking behind Dr. Ruth Stalker-Firth. You've probably seen her critiques, right? Very sharp takes on tech, on AI, but we want to look underneath that, find the foundation for that authority she speaks with.
Yeah, and it's maybe not what people expect. It's actually rooted in some really rigorous engineering. Her PhD, that was EPFL back in 2000, and the topic was Engineer Computer Interaction for Structural Monitoring.
Structural monitoring. Wow. Okay, so like buildings,
Mm-hmm.
bridges, systems that absolutely cannot fail.
Exactly that. We're talking high reliability, precision, managing data objectively. This wasn't just, website design theory. And her work in AI and big data, it goes way back to 1993.
Right, so that's the core of it, that background in systems needing intense accountability, failure proofing. That's the lens she uses now.
It totally informs how she analyzes things. She even developed this pedagogical framework,
Yeah.
a way to break down HCI, human-computer interaction.
Okay, hang on. Lots of people talk about UX, right? User experience. How is her framework different? What gives it that, engineering edge?
It's about systemic analysis, not just surface-level stuff. She looks at 4 parts. First, the human cognitive science, what people expect, how they think.
Right, the psychology bit.
Then 2, the computer itself. The I/O, input-output, accuracy, the actual system architecture.
The nuts and bolts.
Precisely. Third is the interaction. So applying established UX laws, those guidelines we have.
Okay.
And fourth, evaluation. Did it actually achieve its goals? You measure it, it forces you to pinpoint where the system failed the person.
Okay, I see. So it's structured. Can we see how that works maybe with an example? Like that Transport for London Blackwall Tunnel issue she wrote about?
Yeah.
The one with the 90 pounds fine?
Yes, that's a perfect practical case. Her analysis there is powerful because she doesn't just say, oh, confusing design.
Yeah.
She diagnoses it using engineering terms, technical debt, and deceptive patterns.
Technical debt. That's like the shortcuts developers take early on that cause problems later.
Exactly. The compromises that will come back to bite you. And deceptive patterns, those are designs that intentionally, or perhaps negligently, confuse the user into making an error.
Wow. So it shifts it from just like user error or bad luck to something more like architectural neglect. Like the system itself set the user up to fail.
That's the argument, yeah. Prioritizing something else, maybe the bottom line, maybe convenience for the organization over engineering integrity and user safety.
Okay, let's switch gears a bit. AI. She talks a lot about AI, obviously. How does her long history there, shape her view?
Well, her big mission seems to be demystifying AI, cutting through the noise, the media hype, the scare stories, but also what she calls the tech bro braggadocio.
Right, the exaggerated claims.
Yeah, and she does that by grounding it in history, contextualizing it. She actually traces the whole idea of AI way, way back.
Like how far back?
Ancient Greek automata. Her point is that what we're seeing now, these large language models, generative AI, it's just the latest turn in a very long cycle.
So not magic, just another iteration.
Pretty much. She calls it the recurring rise and fall of AI, understanding that history, that previous cycles also had huge hype, followed by, disappointments. It helps you see past the current frenzy.
Makes sense. It tempers the reaction. And
Yeah.
she uses storytelling quite a bit too, right? To connect the technicals with broader issues.
Absolutely. That's the sociocultural bridge. Her talk, When Women Were Computers, is a brilliant example.
Tell me about that.
She traces the job title computer back to, I think, 1731, detailing how the actual work of computing was often done by women, frequently low paid, their contributions essential but often overlooked.
Wow. So human computers. Literally.
Yes, and it connects that technical history directly to bigger questions about recognition, labor, and systemic fairness. It's not just about circuits and code.
Okay, so wrapping this up,
Mm-hmm.
if you had to distill her main contribution, what is it?
I think bridge builder is a good way to put it. She translates that deep, decades-long engineering knowledge, AI, reliability, systems thinking, into these really accessible ethical critiques.
Critiques that are grounded in objective principles, like cognitive science, like those UX laws you mentioned.
Exactly. It's not just opinion. There's a structure, a rigor behind it.
Yeah.
And it really pushes us to ask harder questions.
Okay, leave us with a final thought then. Something based on her work.
Well, if we accept her premise that modern tech should meet a high bar for reliability, like those structural systems she started with, then maybe we should ask ourselves, how often are our anxieties about technology, the ghost in the machine fear, actually masking deeper worries?
Deeper worries about.
Maybe about socioeconomic things like labor, value, Who's accountable when things go wrong? Are we just projecting our cultural fears onto the technology itself?
Yeah.
And how much does the story we choose to believe shape the tech we actually build?